In my previous video, I talked about processor, how it works, and whatever you need to know, and in detail I tried my best to explain processor, how it works. And I also mentioned about quantum computers. So what exactly is a quantum computer? A quantum computer is basically different from the classical computer, which is nowadays getting closer day by day. And let's get into it, what it is, how it works, and why is it so exciting. So let's get into it. Before getting into quantum computer, let's understand how a classical computer works. A classical computer basically works on bits, which are strings of zeros and ones, and they're switched through logic gates, which are basically transistors I talked about in my previous video. These logic levels are 0 volts means ground, and 1 means 5 volts. Basically it's a transistor logic, or TTL for short. Let's talk about quantum computers. So why exactly is it different from a classical computer? A quantum computer uses qubits. Qubits mean Q stands for quantum, and bits are for bits, as I said. So quantum bits, they can, as in the classical computer, can exist in 0 and 1, but there's something different. Initially, the program starts from a string of zeros and ones. What is different in quantum computer is that these qubits can exist in 0 and 1, but they can also exist somewhere in between, like in superpositions, somewhere it can be either 0 or 1. Think about a coin. When you spin a coin, it's moving, so that's a superposition. It can be heads or tails. This is how a quantum computer works. It can be either 0 or 1. As I explained, the bits can be in 0 and 1 in the superposition, as I explained, like in a coin. They can be in 0 and 1 with some probability. Of course, it's not 1 bit. It will be way too many bits as we talk. And after calculating the probabilities, after calculation and superpositions, the resulting number, it is a normal number. So qubits are basically of electrons. They can either spin up or spin down. Spin up represents a binary state 0, and spin down represent a binary state 1. Let's talk about more than 1 bit. It could help you understand it better. We'll talk about 2 bits operation. That would help you get the idea of what I'm talking about. It might sound crazy, but it is interesting and it is amazing. Let's talk about 2 qubits. So 2 qubits means take 2 bits, but they're 2 qubits. They can be either, like in the classical bits, it could be either 0, 0, 0, 1, 1, 0, and 1, 1. It's pretty simple, but here's come the part. When performing quantum operation, they can coexist. It can be 0, 0, 0, 1, 1, 0, 1, 1 all at the same time, and all of them have a probability of existence. And there are infinitely many superpositions. I'll talk about these in a bit, so that would help you understand what I'm talking about. And each of these operations are performed by quantum gates. These are in the classical computer, there are logic gates, and in quantum computers there are quantum gates. So in the superposition, you have all of the 4 states, as I said, 0, 0, 0, 1, 1, 0, and 1, 1. They all have some probability, and they all coexist, as I said. Of course, if all of them have some probability, they will coexist. But this is not a drawback. Like, it might seem crazy or inefficient, but trust me, it has a lot of benefits and applications. In the end, after computation and observation, we have one final result, be it 0, 0, 0, 1, 1, 0, 1, 1. One of them has to be the result in 2 bits. So let's say it is 1, 1, a single basic state. So here comes the important part, increasing the bits, let's say 8 bits or 10 bits or how many you want. Let's perform some quantum operation. Like in quantum operation, due to superpositions, what can be done in thousands of steps in a classical computer, it can be done in like a few steps. Why is that so? As I explained, it is like because of the superpositions, because all of the states coexist, and these states benefit from that, and the operations are done very, very, very quickly, and the results are given you in a few minutes. Whereas a computer, like a classical computer, could take let's say years for that operation. A quantum computer can do it in just a few minutes due to the superposition property. I'm not talking about 2 bits, I'm talking about way more bits. Because that's why the superposition, like in every possible combination is calculated, and that's why in quantum computer you get the result very, very, very quickly. Why is it slow in classical computer? Because classical computer calculates one result at a time, and it cannot do superpositions. And as I said, of course, the number of bits are more than 2. So let's talk about some applications why quantum computer is amazing. As I said before, what can be done in like with a classical computer could take years to solve a problem. A quantum computer can do it in a few minutes due to the superposition. We already do a lot with the classical computer. Why do we need quantum computer? Well, we do need quantum computer for more complex tasks, modeling, simulations, these complex simulations, which in a classical computer could take hours, days, months, and as I said, years as well. A quantum computer can do that in just a few minutes. And most like a practical example would be like weather prediction, or be it whatever which requires high processing power. A quantum computer will do that in just a few minutes for you, and it's very powerful. Basically, the brains, like in the quantum computer, the chip itself consists of superconductors, and it does not require much power or no power at all. But the thing is that it has to be at a very low temperature. It's like 10 millikelvins. 10 millikelvins is like absolutely freaking zero, like absolute zero. And yeah, and absolute zero, which is a very low temperature. This is why like the superconductor is left. Like the quantum chip is kept at very low temperature, so it can perform very efficiently. Like, as you know, a superconductor has no resistance at all, so no power losses over there. But the thing is that it requires a lot of power to cool it down to like that temperature, so we can do the computations. And when you see a quantum computer, like an actual quantum computer, it requires a lot of space, and you basically cannot have a quantum computer at home yet. We might have a quantum computer in the future, but for now we'll be sticking to classical computer for quite a while. So yeah, that's the explanation. I tried my best to explain quantum computers to you, as it's very exciting. I tried to explain it as simple as possible, and let me know what your thoughts are in the comments below, and let me know what you think and like how it could help you in the future, in the near future. And yeah, and I hope you like this video. If so, then like, share and subscribe, and click on the notification bell, and I guess I'll see you in the next one. Peace.